and everybody can hear me, correct? If you
Yep.
can hear me online, give me a thumbs up. If you're sleeping right now, give me a thumbs down. All right. Anyways, so what we're what we're going to talk about today are variables and scope and all those things that you've learned previously, and also naming conventions. Okay. Um, so what I want you to do is I want you to bring up Visual Studio. I don't think I have yet. So go ahead and bring up Visual Studio. And we're going to screw around a little bit, okay? Now I kind of don't care where you put this, um, but I want you to create a mess around project. Okay, I'm going to call mine tester, and we're going to just have a little bit of fun. I don't know why this doing it. And so we're going to create a new project. And I kind of don't really care where you create this. Um, but just remember, we want to create a C sharp, a Windows, and a desktop project. Okay? Has anybody had a hard time creating that in their NA never attended assignment? So everybody's turned that in or going to turn it in, hopefully shortly. I know Mimi, you'll probably you haven't done yours, right? Or did you? Okay, good. All right. So what we want to do is we want to create uh, this right here, a Windows Form app. Okay, and just say next, and um, you can put this under your.
Mr. Abdullah, sorry to cut you off, but is this practice or is this our next assignment or something?
Is it say that again?
Is this some form of practice or is this the next assignment or something we're working on right now?
This is a play around.
Oh, just like playing around. Okay, gotcha.
Yeah, we're just messing around right now. But so if I go here, I can go to I can go wherever I could go under my CIS 130 student. I don't. You go under the lecture if you like, and I'm going to just create something under chapter 4, and we already have some here, but I'm going to create a new project, and I'll say select this folder and call it whatever. How's that? How's that for a unique name? Call whatever you want. I don't care. And yeah, yeah, because you don't have that yet. Okay. And I really don't care where you create this because it really we're just playing around. So you got to yeah, you could just do it on your document under your documents. Okay. Um, are you on campus a lot? No. I'm trying, oh, so exit out of that. So, go to here. Go to right there. And then, all apps. And then go all the way down to Visual Studio. Right there. Nope. Yeah, expand that. And then go down. Right there. All right, and just make sure you're going to be using .NET 8.0. Okay? And go ahead and create. So whenever you create a new project, it automatically creates a form for you. Yes.
For the framework, I have framework 4.7.2 and 4.8.
You chose the wrong one. So go back. So go back. So Windows do C#. Okay. Yeah. Yeah. Well, here's the thing. So framework, I should probably go to like. How you doing? We're creating a new Microsoft, we're creating a new project. So anyways, framework is the old way to do everything. So what happens is when you use Visual Studio, it creates a layer between the operating system and Visual Studio, and which allows you to use all those GUIs. Okay, all those objects. The old way was to use framework, and that only worked with Windows computers. Okay, but .NET allows you to run off multiple platforms, so that's a newer way to do it. Okay, framework is still available to you, but we want to use .NET, and we literally want to use .NET 8.0. Okay. So how you say your name? Yusra? Did I say it right?
Yes.
Yusra? Okay, good. All right. So we're creating a Visual Studio. We don't care what you call it, but it should be a Windows C# desktop version. Okay. And now if we go back to our handout, what we want to do is we're going to create this object. What kind of object is this? The label. And we're going to talk about that shortly, why we name it that. But let's drop a label object onto your form. Okay. So to get your tools your toolbox to show up, you just basically need to do this. Go to View, Toolbox, and then I like to pin mine. So you just click on this pin, and now you have all your tools. Now, these tool objects, they will only show up while you're on the form. They'll be grayed out if you're in code. Okay? because you can't drop and drag them into code. So we're going to take a label and we're going to drag it over here. Okay. And then we want to change its name. And the way we change its name is by what? Anybody know? The properties?
Properties.
Yes. And how do we get the properties up? Hmm?
The
View.
view button.
And then go to properties window. Oh, you get it done F4 too. And I always like to list mine alphabetically, but you can list them as grouped. Now, we want to change the name of that. Whether you're listing it grouped or by alphabetically, you always have to go to the beginning to change the name. And so we're going to name it LBL author. Okay. Sound good? We're just taking our time here. Now, what if I wanted to make this larger? How do I do that? Size? Okay, let's try. So the current size is that. So if I change the width to 60, let's do 100. Let's watch what happens. Nothing. Why couldn't we change it? Anybody know? Yeah, why? I mean, but why? Does anybody know why we didn't change it? There's a property that we need to change. It's a property called auto size. So, and because it's auto size, it only goes as big as it needs to be. Okay? So we're going to switch auto size. We're going to make it false. Okay. Now, I don't like calling it label 1. So I want to call this whatever. I'm going to call it my name. You call it your name. Okay. So how do you change that from label 1? Text. So yep, text. So let's go to text and you can put your name in there. You're the author. All right. And, just for the fun of it, let's change the border. And we said when you display output, what kind of border do we want to make it?
Box,
What?
text box,
Fixed?
text box.
Fixed box?
No, text box.
Oh, no. Not text box. We want to change just the border. So we're going to go here. All right. So let's do the border style. Right now it's a blank border style. We're going to do fix single. Okay. And by the way, we can now make this larger if we wanted to. All right. So properties are like variables for objects. You understand? So an object has a bunch of variables that you can change. We've done a bunch of them right now. Now let's try running this. So how do we run it? We can just click right here with the run button and click run. And it ran, and we're happy our program worked. Okay? Does everybody's program work? All right. Mimi, yours work? What's it saying? What?
I didn't even do it, it's just running that out of.
All right, we'll take a look. But, all right. But this is a very simple program. Now, if we go back to our notes, what we're going to do is we want to change a property. And we're going to change the property of the label author object. We're going to change the property of visible to being false. Okay. So if we click on this object, we can say false. And now if we run this, guess what's going to happen? No object on there. Okay. All right. So you can close down Visual Studio now if you like. And this is just me screwing around a little bit. Okay. I want you to get real comfortable in this environment. All right. But let's talk about variable names. So everybody has taken a class where they've had to use variables, right? All right. So again, variables, you can use uppercase or lowercase. C# is case sensitive. Okay, just like C is. Just like SQL isn't.
No.
So-
It's not case sensitive.
No. But I still use capitalization in my code with SQL because it's more about readability, all right? So, and you know all this stuff. But what you don't know is that we've talked about camel case before, right? And you learned that in other classes too. Swear you? No? Well, anyways, this is camel case. Okay? Right here. So last name would be camel case. And why do they call it camel case? Because every new word is a hump. You know, like a camel. Some camels have one hump, some have two humps. So every new word is a hump. So that's, and it makes it more readable. But in this class, we're going to use something called Hungarian with Pascal case. It's similar to camel case, except you put what type of data type the variable is. Now you don't have to do that, but it's a structure convention that we want to use. So if, for example, I want to find where all my strings are, all I got to do is do a search on str. Okay. And so this is just a technique, but we're going to practice this. Now, when you become big time programmers and you're making $500,000 a year, and you say, you know, that crazy teacher at Henry Ford, I don't like doing it. You can do whatever you want. Okay. But one of the things I would recommend is whatever you do, be consistent. Okay. Be consistent of how you label things, how you name things. All right. Believe me, when you're 2,000 lines into code and you're way away from everything else, you want to know that you named last name str last name. You don't want to have to go look and see what you named it. Okay? Trust me on that. All right. So anyways, so we're going to try to practice this. And now let's talk a little bit about data types. And again, you've experienced data types, okay? SQL Server has the most data types of all, by the way, okay? But we have several data types here. We have a bunch of number type of data types, int, uint, just different things you can use for integer. We have single, float, which is single precision. We have double, which is double precision. We have decimal, which is a precise fractional. It's the highest one. Okay. The other thing is we have that C didn't have is we have something called string. Do you remember we didn't have string in C? Did anybody take C?
This semester.
C, next semester?
No,
Yeah.
this semester.
Oh, this semester you're taking it?
Yes, in October.
Oh, in October.
Yeah, 8 weeks.
Okay, cool. Well, C does not have a string data type. You have to use character arrays. Just a FYI. But I love string. String is very powerful. So, unfortunately, we have string here. Again, you're never going to be tested on all this. You can use a chart like this, and you're primarily going to use int. I think double is kind of the default for decimal places, numbers that have decimal. Everybody know what Boolean is? Okay, let me ask you a hard question. What does SQL Server have Boolean?
Yeah,
Who says yes?
Boolean in SQL Server?
Yeah,
Yeah, in SQL, yeah.
it does not.
But we use true and false for
Yeah, what they use for true and false in SQL is bit.
that.
Bit. Bit is 1 bit.
Yeah, 1 or 0.
So 1 or 0, exactly. And in fact, it's kind of interesting when like, let's say you use Access or whatever, Microsoft Access. If you pull the data from SQL Server, it will take the bit and make it yes or no in Access. So, and why is that important? Because when you're writing an application in C#, you're going to attach to a database. Okay? And we're not going to do that here, but you're going to attach to a database. Here we'll just attach the text files. But in real world, you attach to a database and the database has to communicate with C#. So that's what happens. Okay? All right. Let's go to the next page. And we're going to just try some of these. And by the way, there are going to be methods for date time structure. So there is this, you can use dates and date times, and you can use different objects to help you with that. Okay? All right. Let me ask you all some questions. And you guys can answer online too. What would be a good name for a variable for salesperson name? What would you name salesperson? If you wanted to make a variable for salesperson's name, what would be a good name for that?
Same person.
Hmm?
Same person.
Salesperson, yeah, but, okay, but how would it look? Would it be,
With the data type, you mean?
so,
You want to put the data type?
yeah, how would it, I mean, how would you code that?
You can call it string, str,
Yep,
employee or something, employee name.
so STR
Yeah, employee name.
name,
Employee name. Employee.
sale,
Or sales, yeah, sales.
would you say it again?
STR employee name. Or employee.
SP,
STR.
okay,
Employee. Employee.
every,
No, employee. Employee.
like what?
Employee. Employment.
Employee, oh, yeah, well, why you say employee name when it's salesperson?
His employee idea.
I see. All right, I can buy that. Here's what you wouldn't want to name it. You wouldn't want to name it STR capital NAME. Anybody know why?
What was the question?
Why wouldn't you just want to name it name? STR name. Because there could be other things that have name. Okay? So you want to be specific in what you call something. Okay? Makes sense? Even employee name is stretching a little bit. But it could make sense. If it was an HR database, it could make sense to say employee name. Okay? You can't just say employee, you gotta say employee name. Because it could be employee number, it could be employee ID. So you gotta be specific. Don't worry about, make sure you can read it. I mean, you don't have to make super long variable names, but make sure they make sense, okay? How about for student age? What would be what would you call a variable for student age?
INT, integer, student age.
What is age? How old are you, an integer, or do you say, so I'm 63. I don't say I'm 63.56, okay? INT student age. Okay, so INT, capital STUDENT. The reason I'm not writing on the board is because I got people online too. I could, here. Let me bring up let me bring up a document. Close, blank, so. So yeah, I might say for that, I might say int student age, right? All right. Let me ask you this question. Oh, somebody put SP name. So yeah, I would do maybe the problem with SP name is it's not descriptive enough. So somebody that went into your program might not know SP name. Yes, I agree. It's a little bit too general. All right. So the first one I would have said STR sales person name. Okay. Now, I do want to ask you a question. Why is it a bad idea to put age in a database? It changes. Birthday? That's good. Yeah. Yeah, if you're going to make a variable, do birthday. Okay? Because you can always calculate a person's age from their birthday. Okay? Make sense? All right. Now, this might hold their age while you're doing some calculations. So, okay. But don't put age in a database. All right, social security number. What should that be?
String, STR.
What?
STR.
STR. Why?
That's if you need dashes between the numbers.
STR. It's gonna be the good thing. STR.
STR.
Should be string social security.
So, and really here, you could say SSN. This is a standard that people understand. Now, why do we like to store social security numbers in strings? Anybody know why?
Because the dash.
Nope. Good guess, but no.
We're not gonna calculate it or do any calculation on it.
You never calculate it. You never use it for calculations. And anytime it's a fixed number, okay, you probably want to use strings, especially since if you use an integer, and I don't know if social security numbers can start with a 0, but if they do start with if any integer starts with a 0, 9 characters will become what? 8 characters. Okay? So that's why if it's a fixed thing and you're not using it for calculations, you should probably go with string. Hyphens you don't really need. If you use hyphens, the problem with using hyphens is somebody might screw that up. You know, it's just another thing to screw up. So you can display it with hyphens, but you don't need to put the hyphens in the data. Make sense? All right. We'll run through the rest of these. Invoice amount would probably be DEC. Okay. Data service would be a string, but you would have to be knowing that you always had to convert it. Okay. You have to try it. There's a lot of methods for dates. Product number, probably a string. Okay, because you may use alphanumerics. Also, you have the same problem if a product number, if it was all digits, if it starts with a 0, you would lose that. Okay, and again, you'll have to calculate it. How about GPA? What would that be?
Decimal or double.
It would be what? Double?
Decimal or double.
Yeah, probably double. You just use the default for it. You know, we don't need much precision on that. Invoice amount, we need a lot of precision. Anytime you use dollar amounts, you need more precision. So you might use DEC for that. Okay. Why do you think we need more precision when we use dollar amounts?
Due to the thousand, you may need to include the cents.
Well, yeah, it's not just a cents though. Think if you wrote a program for a banking system, let's say Chase Bank, and you took every, you put every 0.000, whatever numbers here, X, into your bank account. And there's millions and millions of transactions every day. You'd be a rich person, right? And people have done that, by the way. You know, they just peel off the last thousands or hundreds. You know, nobody notices it. That's why you need a lot of precision with dollars amount. Even though it only shows up as 2 decimal points, there, you know, when you start adding all those calculations and all that, there's a lot of decimal points to the right. Okay. So these are just some of the employee picture. This would be it depends what you have. I could tell you what this would be in SQL Server. You know what it is? Binary. Okay. Here it might be image. I'm not sure what data type that would be. So, anyways, and declare statements. In C#, you have to declare your variables. Okay? It's not true in every language. But in C#, you have to declare your variable type. Okay? And these are some examples of it. Yes. I agree with you, Hossein, about Social Security number. But these are how you declare a variable in your code. Okay? You can just declare the variable. You can declare multiple variables of the same data type. You can also declare, you can declare and assign an initial value to your variable. Okay? Here we're declaring 3 decimal. And you can declare an empty string. Okay? And there's another way to do this, and we'll go over that. I think we have gone over it. I did it in the last lecture. Did you? How many people have watched my videos? How many people are honest at least? Mimi, raise your hand. You're honest. Watch the videos. Do the work. All right. Okay. Julia watched the video. Good. All right. All righty. Let's go ahead and let's download chapter 4. Okay. And I'm going to go through all the steps with you for this. Okay. So first, where do you want to download it? Well, you want to download it in your lectures. So let's take a look at where that might be. So you can put it wherever, but what I've asked you to do is to you can create the CIS 130 student under your documents folder. You can do it under your repos folder, if I can find it. Did I put no? I didn't put it here. I know I got a lot of stuff in there. Where did I put that? Oh, under Visual Studios, under Source, under Repos. I already got a chapter 4. I'm going to delete this chapter 4. Okay. All right. So you can put this wherever. Ideally, though, you put everything under your CIS 130 folder. Okay. And then you download the lecture for it. It's, by the way, it's right here. These are your lecture folders. And I forgot to do something in this one, I think. I wish I didn't, but I did forget. So I'll show you. But you right click on that and you're going to extract all. And I always get rid of the folder it wants to create because it's automatically going to create that folder anyways. And it's kind of redundant. It'll create chapter 4 folder twice. So I get rid of that, hit enter, let the download begin, the unzip begin. So on and so forth. And then it'll be complete. All right. Now you can go there and we see that if we go back to our notes, so we've downloaded chapter 4, and we're going to open the scope example. Okay. And what we're going to do is we're going to take a look at this variable right here, this int sales. And what we're going to be learning about is what scope means. Does anybody know what scope means? Did I tell the joke about it's not a breath wash? Scope. You ever see scope? It's it's mouthwash.
Yes, so,
So did I tell that joke?
yeah, but I know the mouthwash.
Yeah. Well, we're not talking about the mouthwash. Scope has to do how long and when a variable is alive or dead in your program. Okay, and we're going to look at 2 different scopes. There's scope, which is method, means that it's only available within the method. Okay, think of it's very similar to functions. Okay, if you have a function and you declare a variable there, it's only available in that function. And then you can have class scope. And what's class scope? It's available throughout the whole class. So any methods in that class, that variable is available to it.
What was the last word? Scope, what was the last word you said?
Scope, class.
Class scope.
Class scope. Okay, and that's right here. So here, so we have a int sales, which is a method variable, but we need int sales in multiple methods. So we need to make it a class level variable. Okay. And I guess we ought to go over this before we go into it. So scope determines what code has access to it. Okay. And if it doesn't have access to it, you're going to get an error. If you declare a variable in the method, it has method scope. If you declare a variable outside the methods within a class, it has scope level. It has class scope. So a variable with a method scope can only be referred to by statements within that method, and a class scope can be referred to by all methods in that class. The lifetime of a variable is the period that that variable is available. A variable with method scope is only available while the method is running. Once it's done, it's done. Okay? But a variable with class scope is available whenever the class is whenever an instance of that class is utilized. All right? All right. So let's go ahead and let's bring up our program that we've just downloaded. All right. So let's go back to here. So we're going to use the scope example. Now, remember for this class, you can either go into the project or the solution. Okay? The project or the solution. Why can we do that? Because in this class, we're only going to have one project per solution. Okay? So you can bring up either or. We'll just bring up the project and we're going to tell it Microsoft Studio. It hasn't been linked with it yet. I'm going to open it. Blah, blah, blah. We don't care about that. But we do have a problem here. Anybody know what the problem is? Let's see. Let's go ahead and try to bring up the scope example here. So double click on the scope example. And let's just, oh, it worked. I wonder, I must have changed this. Did I change this? I didn't change this. Did I change this? All right. I must have changed it. I thought I had a problem here where, oh, I did change it to 8.0. I didn't do it in the other class. I left that .NET 7.0. If you ever come with you see an error that says you need to load .NET 8.0 or you got to load .NET 7.0, don't do it. Go into your project and point it to 8.0. Okay? So you go to project, scope, example, properties, and you change it right here. The target framework is .NET 8.0. Another thing you ought to know is that whenever you see framework, it's using the old version. When you don't see anything, it's using the new version of .NET, which is available to every platform. Okay? All right. I said all that for this. Okay. So let's go ahead and let's try to run this example and let's see what happens. So go ahead and try to run it. And no, we don't want to run. We got 2 errors. Okay. And we see what the 2 errors are. We could click on it. Man, we used to be, why can't we click anymore? Anyways, does anybody know how to bring up to look at the code? The code behind the form.
You right click.
View code, exactly. So let's go to code, view code, or you could have did F7. Okay. So we see that the variable is declared and assigned right here. But look at it, it's inside the button sales click method. See that? And that's why we're getting the errors, because it can't be there. Where do you think it should be? To make it available to every, see, it's using that in sales down here as well. You see that? So where should we put,
In the scope, in the class scope,
where?
to be in the class scope,
Where at?
the class scope, the class, the for-
Okay, wait, I might do a control X, I'm gonna remove it. Okay, where should I put it?
After the, the declaration of the class.
Okay, right here or,
No, outside this,
okay, outside that, okay. So right here,
yeah.
okay. All right, so we moved it. Let's see if we can run our project. Uh-oh, we're still getting errors. Anybody know why?
Maybe line 19.
Yeah, it's what? Say it again.
Line 19.
It's not capitalized, right? See that? So right here is fine, but right here it's not. So we need to name that S.
Can you zoom in, please? Can you zoom in?
Hmm,
Can you zoom in?
and
Zoom in.
oh yeah, my bad. Got it. I should wear my hearing aids. Who thinks I should wear my hearing aids? I got these $200 hearing aids. I don't like them though, but I might wear them so I can hear you guys better. It's not you that's the problem. It's these things right here. All right. And we do have one other place. Okay. So let's try running it now. Uh-oh, we still have an error. What's that? Ooh, okay, we need to read on. We're getting some other errors now. All right. So let's go ahead and let's read on to our handout, and we'll come back to this program. Named constants. Everybody know what a constant is? It means that the value doesn't change. Okay. Some languages let you do it, some languages don't. C# you can. You can name a constant. Does anybody need to go to the bathroom or anything? You all good? All right, we'll plow through. If you need to go, you can always go. Okay. So, you define a constant. You start off with const, okay? And then all the rest is about the same. One of the conventions that we like to use here is that if you are going to make something a constant, if you're going to make it, use all uppercase, okay? You don't have to do that, but that way you know that you're dealing with a constant and you can't change that variable because it's not a variable, it's a constant. Okay? And some obvious ones, the most obvious of all of them is pi. Pi has never changed. You know that, right? So, pi, right? But you can see that the syntax is pretty much the same, is naming a variable, except you put the const at the beginning. And of course, you assign something to it. it wouldn't make any, it would make 0 sense to declare a constant and not put a value to it because you couldn't. You see? So that's why you're going to always assign a value to it. All right. All right. Who can define for us the difference between implicit and explicit? All right. I just wanted to see if anybody could. Implicit means that the programming language will implicitly do a conversion. For example, I can assign an int variable to a double or a decimal, right? Because it's easy to convert. So, for example, I can assign, and we're going to try some of these, okay? We're going to try some implicit conversions using numbers, okay? But let's just walk through this. So implicit means the developer does not have to write any extra code for conversion. It's automatically done by the C# compiler. You can assign a double or int values to a double variable, but you cannot assign a decimal value to a double variable. Why? The range of the double value is larger than what an int value can be. Therefore, there can be there would not be any data loss when the int value is assigned to a double variable. Okay, it is implicitly converted. A decimal values can have up to 28 digits of precision, while a double can only have 15 digits of precision. Therefore, there would be data loss. So a decimal cannot implicitly be converted to a double. And the same goes here. Now, the only thing interesting is that a double value can potentially be much larger than a decimal on the left-hand side, so you can't implicitly convert that either. Okay. So let's try a couple things here. Okay. Let's go back to our program. And we're going to try some conversions here. All right. What I want you to do is I want you to put another label here. Okay. And we're going to drag a label onto our screen. And I'm going to put a border around it so we know that it's there. Okay. But I don't care about the rest. I'm using this as a test area for the output. Okay. And we'll call it, just so we know what we called it, we'll call it LBL test. Okay. And I made it fixed single border, and I'm going to change the text to be nada, nothing. Okay. Oh, I'm going to change the auto size. So we can have it relatively big. So I'll make that. Oh, false. I thought it, oh, wait a sec. Oh, I can, what I'm going to do is I've already changed that, so. Oh, auto size, oh, it's true. I'm reading the wrong one. I want it to be false. Okay, and we're going to just make it a little bit bigger there. All right. So we're going to display our result here. And every time we hit this 3% commission, we're going to change this. Okay. It's just a way of testing. All right. Oh, and by the way, we have to switch some of these out and going forward if we want this to convert. So we'll take care of that too. All right. Now we'll do the 5% because it's at the very end. All right, so we'll just call this test area. And so, for example, we're going to declare a variable here. We'll just, we'll call it int test. And we'll make it equal to, I don't know, 1, 2, 3. How's that? Okay. And then we're going to send that to that label area. So we're going to assign LPL test dot text, and it kind of guessed everything we were going to do. Is that kind of cool? So IntelliSync actually guessed what we wanted to do here. All right. Now, a couple things to notice. Because this is an integer, I had to, it had to use this explicit method to convert the integer to string. Okay. So if I run this, let's see what happens. Oh, it's still not going to work because we got a couple other errors, don't we? Yeah. Let's take care of those errors. So we got an error on line 33. What's that? What's the problem there? Is that we've got to convert int sales. We got to convert these two things to be a DEC, a decimal. So how do we convert this? We can do, let me see if I got this right. So to convert this one, we have to do M, because the default for any decimal one is going to be double. So we're going to use the M, which I don't know why they use the M. Okay, but you use lowercase or uppercase M, it'll convert that. Okay, and we have to also convert this. Okay, so, and then it would be the same thing over here. Okay. And again, we have to put the M here. And believe me, I forget the syntax all the time. Let's go ahead and try it. Okay, it worked. Now, our test case. Oh, I did 5%. Okay, and it worked. So I was able to convert an integer to a string. explicitly. Okay. All right, let's try this. Let's say I made this a string. Okay. And then I'm going to switch this. And what do I have to do for a string?
False.
Yeah. And will this work?
We don't need to convert it to string.
Yeah, you don't need to. But do you think it'll work? Think so? How much you want to bet me? Well, let's check it out. Let's see if it does work. No. And the reason it doesn't work is because this is a string object now. It doesn't have a toString method. Okay? Because it doesn't need one. So we literally would just have to do this. Make sense? Uh-oh, I still have an error. 52. What did I do wrong here? Too many characters in the character. I might have to use double quotes. Let me try that. Let's see if this will work. No. Oh, anybody know what I did wrong? You got to use the full word string there.
String.
Yeah. Yep. I messed up. All right. Let's try it now. So if I hit 5, it works. Okay. Now I'm kind of curious if the toString would work now. I don't think it will. Let's try it. Maybe you were still right. Let's see. Let's see if this will work. That worked. So you were right. What do I owe you? Oh, you didn't bet. All right. Okay. So this is an example of an explicit conversion. Implicit means you don't have to put anything special. Explicit means you do, even though we really didn't need that. Right? All right. Let's go back. So we got all these conversions here. Okay, and you can see how these are all working. So what we want to try to do now, let's try to do some of these examples, okay? So let's go back to our code. And so we got this little test area going here, okay? And we're going to switch this back to an int. And I'm going to just declare these variables. Okay. kind of knew what I was going to do. We'll do double here. All right. So, and then, whoops. In whatever we declare, we're going to have to put that down here, right? So let's try, let's give all these a value. Okay. And all right. What's wrong with this one, by the way? Anybody know?
Space between the operator and the number.
You have to put M. Okay. So, and then, so if we try to, whoops, I thought I had this as double. Okay. So we can convert any of these to a string. We can do the int. We've already seen that. We can do the dec for DEC. Okay, so if we run that, okay, we click there, good. Okay, and we could do the same thing with the double, right? Click there. I only put 50, didn't put 50.00. Okay, we're good with that. Now, just to prove that this would work, if we did this 2.5, it'd be fine too. Okay, makes sense? You good with that? All right. So let's try this. Let's make int test equal to this. What's going to happen here? Will this work? Let's try it. Nope, it won't work. And neither will double. Okay. None of those will work. Now, if we wanted to convert DEC to test, what would we have to do? We'd have to do this. Okay. And let's see if this works. Nope, didn't like that. Oh,
Type DEC.
test does not exist in the current context. Oh, my bad. So we're going to make DEC. So let's try running it now. It works. Okay. Now, what if we convert double? What's it going to do? Let's try it out. double. And we go ahead and run it. Click that, converts it to 50. All right. Let's try something else. What if we make this dot 5, 5? What do y'all think will happen? Will it be 50 or 51? Anybody? Now let's try it. 50. Okay. All right. And we could actually, there's actually methods around this up and all that. Okay. So we could round it. But it basically, when you just convert it, it's going to truncate whatever it can't use. And again, we could run through this all night, but I'm pretty sure you would be bored to death. All right. All right. Just a few more things for tonight. Okay. The last thing we want to work on tonight is this idea of parsing. Okay. How many people have heard of CAST? CAST. Casting.
Yes?
Yeah. C-A-S-T.
Yeah, yes, in SQL to convert.
Yep. Yep. So CAST is a way of converting from one data type to another. Okay. Now, for C#, we use something called parse. And something else called try parse. Okay. So this will be part of our assignment number 1, I believe. Okay. So first thing we're going to try to do is we're going to try parse. Okay. And now let's go back to our example. All right. So we're going to use int test instead of int hours worked. And we're going to try to use the parse method for an integer. And we're going to try to parse this into an integer. Okay? Or cast it into an integer. So let's fix our code. I'm going to get rid of some of this. Okay. All right. All right. All right. So what we're going to do here, so we have this variable, this integer variable. We're going to make a string variable. Okay. Oops, I better spell string right. And we're going to, we'll call it str test. See how I'm using all, let's use single quotes this time. Okay. And so what we're going to do is we're going to, we're going to do an int and use the parse method. It's right there. Okay. And we're going to parse this string test into that. And then we're going to print that. Okay. Very simple, right? Let's try it. Let's see if it works. So at the end, when we press the 5% commission button, we should get 50. Uh-oh, I got an error already. Too many characters. String test, blah, blah, blah. let's make this double quote. I can never figure out when to use single quote or double quote, tell you the truth. So let's see if this will work. Yep. All right, so we should get 50 here. So it worked. All right. So you good with that, right? Everybody understands that? All right. Here's the problem with parse. If your user makes an error, okay? Let's say we weren't getting this from a variable, but we were getting it from a text box. Okay? Let's say I accidentally put in an A. Let's see if this runs now. So watch what happens here. Not only does it not work, but it blows up your program. And this is something we don't mind getting runtime errors when we're testing our program, but we don't like runtime errors when our programs are in production, right? Yeah. Okay. So anyways, they've created another thing for us. All right. And what they've done is they've created a try parse. So this will be the last thing we look at tonight. So I still got the program. I got the program right? Oh. Well, anyways. Hopefully I forgot to stop the program. All right. So instead of using the parse, you can use a try parse. Now what we have to do is we have to create a Boolean value for it in this case. So we're going to create a Boolean. We'll call it bool. And we'll call it BOO and parse. Yeah, we call it whatever we want, really. We'll call it boo test. All right. All right. So right here, we're going to assign true or false to Boolean. Okay. And it's going to be dependent upon our try. So instead of doing a parse, we're going to do a try parse. And the only other thing we have to do here is that if it does work, we want an output for it. And our output would be int test. Okay. So let's do it with a valid one and let's see what happens. So if I run this and I click it, it works. Okay. Now I want to, just to prove it, just to show that it does work, I'm going to concatenate the Boolean.
It's out a keyword.
Is what?
It's out a keyword.
Art?
Out.
Out, yes. It is a keyword.
What does do?
All right, I'm going to explain it.
Okay.
What? Let me do this first. Let's just go ahead and run it one more time. Okay. Let me put a hyphen between this two. Okay. So if we run this, we click at true. If it's true, out means that if it's true, it's going to assign that variable that's after out the value. Okay. So right here, if this turned out to be true, okay, if it can explicitly convert str test to an integer, it's going to assign that integer that str test value to the integer right here. Okay, the variable we made. Okay. And it's also going to assign the Boolean test variable true. You see that? All right. But let's try putting A in here. Let's see what happens now. So if we run this now, and I click there, the Boolean is set to false, and the variable integer, the int test variable, is set to 0. Okay. So this is how we can do a try. Has everybody heard of try? You different languages. There's try. You try something. If it blows up, you go to run this code. If it works, you just keep on going. You're going to see that in SQL Server. It's in C. It's in every language has its version of try. Okay, including C#, and this is a part of it. So we're trying to convert the string variable to an integer. If it can't do it, then instead of blowing up the program, we're going to assign it the Boolean value to false. And then you can do other things if you would like. Okay. And it's going to set the variable in test to 0. So, anyways, any questions that we need to address? All right. Just a few things. Your assignment number 1 is due 2 weeks from Monday from today. Okay. So make sure you start working on that. I'm going to be switching some of these dates around because they actually came from last year. So, but this one's correct. Okay. So do Monday before midnight. Make sure you do the toe chart as well. Okay. If you didn't do the NA assignment, please do it. You have until Wednesday to complete it. Okay. I'll give you 4 points if you get it done by Wednesday. All right. Because you would have lost 1 point. I'll give you a break. How's that? Because you haven't been able to load Visual Studio. It's just 1 point though. So, but that's what's going on for the next few weeks. Any questions or comments? All right, I'll put the recording out there for you.